Should we be scared of AI?
It's natural to feel scared, but I think that fear is slightly misplaced.
What is the fundamental difference between using AI, like probably building a software application with RAG, vector databases, and all those stuff, and also building the tech, like the deep tech stuff related to AI, which is something that you are doing? Is it because of the pay, or you just feel that software engineering has no future?
How we are always surrounded by great minds. They're like the top 1% of the entire crowd. How good the discussions are, how people are discussing about the exact math behind it, or the papers, or the technologies and everything. Someone who's using AI blindly without knowing what's happening in the background. And things can fail at math level or statistics level, and you wouldn't know basically what's happening wrong. I switched to Microsoft. It's been roughly 4 months as well. This is like a dream goal, basically, right? To work in a big tech company, something like Microsoft.
What are the extra skills that you would need to become a data scientist? Hey everyone, welcome back to yet another tech podcast on my channel. So this is the first of a series of the podcast that I'm doing where I'm hosting a lot of interesting and industry experts from the current software engineering industry. And in this episode, I have got Anay, who is currently a data and applied scientist at Microsoft. And we are going to have a lot of interesting conversations, especially in this era where every conversation revolves around AI. So welcome, Anay. Thank you so much for joining in. Why don't you give a brief introduction about yourself to the audience?
Sure. Thanks, Siddhi, for having me. Yeah, I'm Anay. I have started my professional journey back in 2020. I started as a business analyst back then at Shell, which was a non-tech role at that point of time. It was sort of like a proxy PM role, where things revolved around what to solve for, how exactly should we plan the roadmap for the product, what feedbacks are we getting from different stakeholders, how to plan the releases and everything. So completely different side of world. Then I moved to a data science role. I wanted to get more into tech. I had my interest there, and I felt that I could add more value there. And that's when I transitioned into a data scientist role at Shell itself internally. I had a really good time working there. I got to try my hands on a lot of different problem statements. Started with like basic classification, document classification and everything. Then moved to regression, where we were doing price prediction, commodity price prediction, and some price sales elasticity as well, and somewhat of time series prediction as well, like what are the prices going to be in near future and longer terms and everything, different energy markets and everything. So interesting set of problems, really huge with numbers, especially the price prediction part. I still remember we were working in the US wholesale markets where billions of gallons of fuels were being sold, and still remember that 10 raised to the minus $4 of error usually accounted for like $250,000 annually over sales. So higher stakes.
Correct.
Yes, but great learning, and I had really great mentors there as well. And then I decided to switch companies. Basically, I wanted to try a different environment, different market, different domain. So I thought, what's best than e-commerce? So I joined Myntra at that time, which was a very great company to work at from a tech perspective. And I was really surprised by how fast things move over here. Shell was an MNC, though things were still stable, and things used to take time and planning for longer horizons. Myntra was slightly opposite. We were trying out different things very rapidly. We were prototyping, testing out, validating things very rapidly, always working on the new tech and working on almost all possible domains of machine learning. There was a use case everywhere, and we had more accountability, more responsibility for what we build, what we own, what we ship, what we deliver, and how we see the impact of it. So again, great environment. And recently I got an opportunity to work with Microsoft as well, and I switched to Microsoft. It's been roughly 4 months as well, and this is like a dream goal, basically, right? To work in a big tech company, something like Microsoft. Everyone wants to get there, and this is my chance of being there. And I'm really enjoying it so far here. What I like about here is how we are always surrounded by great minds. They're like the top 1% of the entire crowd, and how good the discussions are, how people are actually discussing about the exact math behind it, or the papers, or the technologies and everything, and especially the impact also. So Myntra, even though it was at a good scale, it was limited to mostly to India, but this is global. and we have 10 different type of customers serving in 10 different regions. So we have to account for more things. We have to be more careful while shipping things, have to validate few more things, and the impact also is multiple folds. So it's a great learning journey so far, and I'm looking to deliver more.
In 3 different domains, and you understood the user journey.
Yes.
That's very nice and comprehensive. Yeah. So my first question to you is what me and my viewers would like to understand, that as a data scientist at Microsoft, what does your role really entail?
So my role as a data scientist is, if I were to put it simply, is like a translator. So it's about decoding what the customer needs or what issues other customer is facing, and translating those open-ended fuzzy problems into a mathematical model and validate it at scale, basically, if it's working or not. And so to give you an example, there may be things like, if you take an example of an e-commerce app like Myntra. So the customers may give a feedback that the search is not really working that way. So good and bad is subjective over here. So we need to validate things like how much time are users spending on search. We have to come up with metrics like what's the scroll depth, how much time are they spending, how much are they using search, and if it doesn't seem right, then we have to come up with some hypothesis and build a model and then validate it. So something like maybe each user has its own preference of brands and size and type of clothing. So even if we can personalize the results based on that user, then maybe they'll find what they're looking for more quickly, and they'll find the right things. So we either build a model which accounts for personalization, then validate if the numbers are improving, and then maybe run a A/B test to see that the results or the uplifts are actually significant, not just due to random chance. And if everything's work out great, then we can deploy it and then continue to monitor it.
Correct. So, like, what is the difference between a software engineer, right, and a data scientist? And have you been a software engineer yourself when you got started in this area?
Software engineers build the system that follows the rules. Data scientists build the system that learns those rules. So AI engineering is basically like assembling intelligence. You take out different components and assemble it together to create a solution. Whereas data scientist work is more about building that intelligence in the first place. I have done a software development internship for 6 months. So I have some idea of both sides of the world. So the way I would describe the difference between software engineering and data science is that software engineering work is very deterministic in nature. You have to explicitly define what needs to happen in each scenario. And on the other hand, the data science work is more probabilistic in nature. You cannot define what needs to happen in all of the scenarios. You are just optimizing for a outcome or generating statistically valid results, basically. So again, to give you an example on this, I'm sure everybody must have used some AI Copilot, AI code editor itself. So let's take an example of Copilot itself. It shows you inline suggestions of what you are most likely to type, the code completion part, basically. And the engineering part in that is basically to ensure that the pop-ups come up every time. And every time a user clicks the pop-up, the code or the suggestions correctly gets rendered into the code within the threshold of latency and everything. That is the deterministic and engineering part, basically. But the data science part would be basically, out of all the possible scenarios, how do we decide what is that the user wants? How do we maximize the outcome that this is what the user actually wants, or this is what the user is most likely to click? So that's the difference.
That was a very nice explanation. So as we stand in the cusp of this technological revolution, right, everyone is throwing a lot of buzzwords, and as a result, people who are getting started in this industry, right, they are very confused because they don't know what to learn, right? So my first question is, like, what is the difference? What is the fundamental difference between probably using AI, like probably building a software application with RAG, vector databases, and all those stuff, and also building the tech, like the deep tech stuff, right, related to AI, which is something that you are doing. So how would you differentiate between the two, and how do you first figure out that this is my niche, this is where I want to be?
Right, that's a good question, and it has. So these two areas have become more overlapping, especially after the rise of these GenAI tools and LLMs and everything. So I would say the difference between like using AI and building AI is something like using AI is more like assembly work. You take out different components, a machine learning model or embedding model, and a vector database and some set of metrics, and put things together to build a solution. And data science problem is more about building that intelligence itself. So if you're building a model, do you train something from scratch? How do you tune it to your specific use case? And yeah, building that intelligence basically. So again, like to iterate with an example, you can say like, take an example of use case which is as simple as summarizing notes. So in Teams they have an option, right? So after every meet you can summarize. So in that feature, if you see the using AI part is basically getting the transcriptions out, using an embedding model to create embeddings out of it, then feeding it to an LLM, asking it to generate a summary, then pass the output and show it in the right format at the right place. So that is all using AI basically. And building AI is actually knowing how the summarization is working. Is it actually working or not? Is it summarizing what's important or just saying what's or important? Focusing on more on what has been said most, and what is the right metric? How do you validate that these summaries are right or not? Do you need to fine tune the model which you are using for generic or some specific use cases, or are you using a generic model? So things like that basically.
Okay. So let's say if a fresher is watching this or someone who is very new to this industry,
Yeah.
and he wants to get into this, explore this data scientist, this part of the other part of the AI, right, where they can get into deep stuff. What are the skills? Like obviously we know that for software engineering we need DSA and system design and OS and the basic fundamental stuff. What are the extra skills that you would need to become a data scientist?
I would say, as a fresher, you don't need to pick a lane first. I would say rather just start with the fundamentals first. Study object-oriented programming, data structures and algorithms, even classical machine learning algorithms and everything. Try your hands on these things because these are the base for both the parts basically. And get your hands on few projects, see what you can build, what are you good at, what interests you more, and where do you think more opportunities are there. So try out everything, figure out your options, and then decide basically. And that's what I also did basically. If I were to give my example, I started learning data science in college. I did my major minor projects in data science. I was into data science. But then I did a software engineering internship also for 6 months. And then after that, I even worked as a non-tech role as a BA chair. So after trying everything, I realized that data science is something which aligns more for me. That is where I can add more value and that is where I see more opportunities. So I again made a transition to a data science role, and that's what I've been focusing more on and going deep into.
Got it.
So if you love optimizing systems, then software engineering is for you. But if you love optimizing data or models, then data science is for you.
So in case you want to reach out to him and get a personalized guidance, I will be attaching a link to a Google form in the description down below. So make sure to fill that form out and he will be taking a look at it and you will be able to ask questions. So if that is something that interests you, do check that out. So now also another question which pops up in our head related to these AI heavy roles is, do you need a lot of deep maths stuff or statistics or things which are like a lot theory based than the practical coding stuff that we are used to doing in software engineering?
I would say that's a good question, that you need maths to actually get into data science. So I would phrase it like that it's lesser than you think to get started with. You can train a model on even fine tune and build a whole system in an afternoon these days. But to actually go deep into the stuff, you need to understand what's happening behind the scenes. There are tools available and wrappers available using which you can build entire models, train it, and even validate and get some metrics out of it. But to actually know if that metric is successful, if that metric is valid, and things like if you're actually solving for the right problem, is your model actually understanding the right patterns, you need to go deeper and understand what's happening behind it. So like even with these generative AI models, there are this issue, right? The longer the model runs, the lesser the probability of it giving the right answer decreases, like exponentially, token by token. And that is a problem which you cannot solve just by writing more code or using 10 other tools. You have to go much deeper, understand what is happening in terms of probability, statistics in the ground layer, and that is how you would solve it basically. So the more you go deeper into, the more math is what you need, and that is what will separate you from others.
How much math are you using in your current role?
So in a day-to-day setup, we don't use it generally, but we really have to get deep into it when we are using a model or deciding which model to use, figuring out what patterns to learn or what exactly is that we are solving for. So we can blindly use 10 different models and see what works out, but that's more like hit and trial guesswork. You're not actually intentionally understanding and solving the equation basically.
Got it. So you also mentioned that you found more opportunities in the going forward in the data scientist or the data science role than software engineering. Is it because of the pay, or you just feel that software engineering has no future?
That's another question.
It can be a personal take.
So I wouldn't say that software engineering doesn't have a future. It is still relevant, but I chose data science because that was more aligned towards me. I find data science to be more interesting, that each problem has it's different in itself. You have to research and solve for it differently. Software engineering works becomes more monotonous at some point of time, and a lot of it has already been started to automate basically. Whereas in data science, things like coding and experimentation and everything has been automated, but you still need human judgment to decide what actually is worth solving for, how do you validate if the results which you're getting are actually useful or not, and if you're solving for the right problem. So all of these things.
I think most of the generic applications that we build in software engineering, those are mostly solved problems.
Yes.
As a result, they have been well solved and well researched and well documented. The AI is able to handle most of them, 80% of them really well. But what I understood is, like in data scientists, there's still a lot of human research which needs to be done to make the model more and more effective. Cool. So now coming purely from a standpoint of becoming a data scientist engineer, right? What are the skills? You can be very specific about the tech stacks, some sort of math concepts, stat concepts that someone needs to learn. Whatever is in your mind, the important ones, if you can tell that for the audience.
I would say that in the age of LLMs and GenAI tools, it's never been easier to skip fundamentals more than now, basically. But that is where it is even more important these days. You should actually start from fundamentals itself. Like anyone can build an AI system in a weekend using these tools, but unless you don't understand what's exactly happening in the ground level, how exactly things are working, you are just again someone who is using AI blindly without knowing what's happening in the background, and things can fail at math level or statistics level, and you wouldn't know basically what's happening wrong. Code-wise, everything would be perfect. So start with the fundamentals first, learn the maths behind it, the statistics, hypothesis testing, linear algebra, and then work your way into classical machine learning algorithms. How exactly do they work? The assumptions behind it, the derivations, the loss functions, and everything. Then move towards deep learning. How exactly does a backpropagation works? What are the issues with neural networks? How has that been overcome? So there's a long journey of evolution which has happened in this field before LLMs as well. So it's not like LLMs just happened in a year or something.
Right.
So how has things programmed? What were the challenges which were faced? How were they overcome? How were they solved? And how exactly these things solve for them mathematically. So the more you understand, the more you'll be able to make better calls in what to use, how to use, and how to tune. So
right. And any specific resources that you followed to like learn these things, learn AI, whatever made you?
To answer about the resource part, something which I felt would have made more sense for me is like a proper structured course, because there are tons of resources available online. You can learn 10 different things from here and there, but you wouldn't know like what to learn from where, and you have to spend a lot of time researching how do I study this from where and how do I test that. So a proper structured course where you get everything in one place actually saves a lot of your time and bandwidth as well. And for me personally, that was Scalar. I had enrolled in the data science and machine learning course from Scalar back in 2022.
Okay.
And that turned out to be really useful for me. So before the course, I did realize that there are a lot of other things other than academics also, which we need to actually understand to get into a data science role, basically. So things like academics is one thing. Obviously, you need to understand in depth, basically, how exactly things are working. But you also need to know how things work in real life scenarios. How do you actually build system in real time, get some hands-on experience? Then how do you even, let's say, prepare for interviews and everything? So all of these things actually make a difference, basically.
Got it. So for you, you are saying that a structured course basically help you out.
Yes, it helps you stay consistent and track your progress, and yeah, basically.
Got it. Okay. So one last question before we end this podcast. Like for someone who is already researching and working, in this AI field, and you probably get to see more of AI from the back end level, because we are just probably the users of AI as a software engineers, right? We don't get to see what's going on the scenes. And probably you would be the first to understand the optimizations of the research that is being going on to make AI, the models better than what it is today. In that context, should we, or should the engineers, not just software engineers, but other roles related to tech, stuff like that, should we be scared of AI?
I understand that's a natural concern that since things are evolving so fast, a lot of jobs are being automated. It's natural to feel scared, but I think that fear is slightly misplaced. I think Microsoft CEO Satya Nadella also has responded, has said a great quote basically on this, that AI is like a scaffolding to human potential. It's not a substitute for it.
Correct.
It can enhance what you are doing. It can amplify what you can get done in certain amount of time, but it cannot fully replace you.
But what are the things it is like looking to replace right now? What are the states?
So whatever low-level tasks or monotonous tasks that we were doing, which were taking most of our time, that is somewhat is being replaced. Like things like writing code, setting up experimentations, and training models end to end. So these are the things which AI can really help you get done faster with. Basically, you can set up 10 different experiments, try out 10 different things, and write a code for everything. That saves a lot of your time, but it cannot decide for you which model does the best. You still have to experiment.
Right.
And what problem is actually worth solving for in the first place? How exactly do you know that the results which you're getting are actually useful and scalable in the real world, or is that statistically valid or not? So you still need human judgment for that, and that comes with a lot of human expertise and by having worked hands-on on it, basically.
Right. So AI is probably enhancing our critical thinking more because it's taking care of the monotonous task in any field.
Yes, exactly. It's like your co-pilot. It shouldn't be your autopilot.
Right. Thank you so much, Anay. Thank you so much for taking this time out on a Sunday afternoon and agreeing to do this with me. So Anay has been very kind to actually, help you guys out if you have any further questions, because these were my questions. But if you have any questions and if you want to reach out to Anay for any sort of help or mentorship, there's a form that I will attach in the description down below. So please fill that form if you want to get in touch with him, and he would be more than happy to help you out. And that's it for this conversation. Thanks again for joining in. In the next conversation that I'm going to host, another interesting person, techie, who's shifted from a service-based to a product-based company. And we are going to talk about the exact engineering mindset shift that he had to make this possible. So stay tuned. We'll see you in the next video. Till then, stay safe and goodbye. And don't forget to fill out the form in the description in case you want to enter. Thank you so much, Anay.
Thank you. Thanks for having me.